Okay, this is the P3 paper from October 2023. This is question number 7, which is going to be a differentiation question in the main, differentiating using the product rule. We're going to be differentiating exponential functions. As you can see here, there's a little bit of work at the start on range, but let's have a look at this question then. Quite an interesting question, this one. So question number 7, it says, we have the function fx is equal to this exponential thing here. And we can see the graph. The graph's going to help us, and it says, can we find the range of the function? Well, looking at the graph then, I can immediately see that the range of the function is going to be from there to there. Okay, we can see that it does actually hit at 0 at those 2 points. So all I need to do is to work out that value there, and let's say from that value there, the maximum value for y is just f0. So let's go ahead and actually do that. Part A, explain to the examiner what I'm doing. So from graph, y max is just equal to f0. So let's just put f0 in. f0 is then e to the minus 0, but e to the 0 minus 3 squared. Well, e to 0 is 1, so 3 squared is 9. 9 times 1, we get that f0 is equal to 9 there. So that means that my range is 0 less than or equal to fx less than or equal to 9. And we're going to include the 0 and the 9 there because we can see it does actually hit at those points there. So part A, not too bad. Part B, show that f dash x is equal to, so that's simply going to be using the product rule, isn't it? So let's give myself a little bit of space here to do that. We've got that fx is equal to e to the minus x squared multiplied by 2x squared minus 3 all squared. So I'm going to say, if I'm doing that, u is going to be equal to e to the minus x squared, and v is going to be equal to 2x squared minus 3 squared, and I'm going to want to be able to work out du by dx. So the differential of an exponential is the function itself, so e to the minus x squared, and then simply multiplied by the differential of what's up there, and the differential of what's up there is minus 2x. So minus 2x e to the minus x squared is that differential. And for the second one, we're using the chain rule, but at this level you should be able to do it really, really quickly. I've got something squared. So if I've got something squared, differential of that is 2 lots of the something, multiplied by the power, take 1 off the power, multiplied by, similarly to the last one, the differential of what's in here, and the differential of what's in here is going to give me 4x. Let's just tidy both of those up before we start putting them in. That's 8x, 2x squared minus 3. And then f dash x, I always tell my students, just write out the chain rule, write out the product rule or the quotient rule each time. It just means that you're more likely to remember it. And also it means that when I'm subbing values in here, hopefully I won't make any mistakes. So it's u dv plus v du. u dv is those two. Just think about how you're going to want to write that down. I'm going to write that as 8x, then I'm going to put the 2x squared minus 3, and I'm going to put the e to the minus x squared, plus u dv, plus v du. v du is those two, which means that the minus will be in there, minus 2x e to the minus x squared, 2x squared minus 3 squared. Now, even before I look at what we're trying to get to, you just know that you're going to be taking out an x, you know you're going to be taking out an e to the minus x squared, and you know you're probably going to be taking out a 2x squared minus 3. So just try and factorize and take as much as you can out. I think I can take out 2x, I think I can take out an e to the minus x squared, and I think I can take out 1 of the 2x squared minus 3's, and if I do that, well, I'm just left with 4 in that first term, and the second term is 2x squared minus 3. Now, at this stage, you might want to go back and have a look and see what we're going to be trying to get to. But yeah, we're very, very close to that already. So tidying that up is 2xe to the minus x squared, 2x squared minus 3, and then that's all 7 minus 2x squared. So not too bad for that one, for part B. Then part C, interesting question here. So it says, given that the line y equals k, where k is a constant, and k is greater than 0, that's going to be important for getting rid of some of our possibilities, intersects the curve at exactly 2 distinct points. See if you can find out what k can take, the range of values that k can take. So y equals k, let's just tidy this up here. Y equals k is just a straight line. Oops, excuse me. It's just going to be a straight line horizontally that goes across. So that's y equals 1, y equals 2, y equals whatever. And what we want is for there to be 2 solutions. So if I'm bringing this down here, there are no solutions here to where the 2 lines meet. At that point there'd be just the one solution. Okay, so we know that if I had that there as y equals 9, so if I then, let me just use the magic of this to get another line up there. Anywhere as I'm going down here, then there's 2 solutions. Okay, look, there's 2 solutions there and there. And then say, as I drag this down, carries on 2 solutions, 2 solutions, 2 solutions, all the way up until this point here. And at that point there's more solutions there. Now, what's that going to be? That's going to be, let's call that y equals k. And then if we keep going down, there would be 2 solutions at that point there. But remember, we've said k is greater than 0. So if k is greater than 0, really, the range I'm looking at then is going to be within that set of numbers there when we're trying to find the range of values of k for which so just to make it clear, where there are 2 distinct points as we're going through and looking at this. So let's make it clear to the examiner what I'm saying, and hopefully make it clear to you guys. From the graph, the key values are going to be y equals 0, but, well, let's just say y equals 0, y equals 9, and then y equals k, where k is the local maximum. But k is greater than 0, so y equals 0 is not involved. Now, I don't know whether you necessarily need to say that, you can just put it in the answer, but what we're basically looking at, if we want to find for k, that's going to be where f dash x equals 0. This point here, and this point here are both where we're getting a local maximum, where we're getting the differential is equal to 0. So that's the one that I'm really going to focus on most of all. And if the differential is equal to 0, I'm going to get 2xe to the minus x squared, 2x squared minus 3, 7 minus 2x squared will equal 0. So what do I get from that? Well, I'll either get that this thing's 0, this thing's 0, or this thing's 0. Remember, when we're looking at these, this comes up quite often. E to the minus x squared, that bit can't be 0. Think about what the graph of e to the x looks like. We have an asymptote at 0. So this is going to give me either 2x is equal to 0, 2x squared minus 3 is equal to 0, excuse me, or 7 minus 2x squared is equal to 0. So this is going to give me x equals 0. This is going to give me x equals, I'm going to do this quite quickly simply because I want to be thinking about our explanations. Root 3 over 2, and we're going to plus or minus that, and this one would give us x equals plus or minus root 7 over 2. Now, if if x was equal to 0, that's where I get f0 being 9. If x was equal to the root 3 over 2, I'm going to get f of, let's just go and put it in there. When I do that one, that works out to be equal to 0, and when I get my f of plus or minus root 7 over 2, that's where I get some value here. It works out to be e to the minus 7 over 2, all multiplied by 16, so it actually works out to be 16e to the minus 7 over 2. So if I then go back and look at what's going on with the graphs here, then we're getting the situation where maximums, local maximums and minimums would occur here, 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 and here, and we can eliminate some of those from what we were saying. The values we're interested in then are these two, and those two are coming from that one there. Okay, so when I'm now trying to work out what the range of my answers is going to be, k is going to work out to be between 9 and the value there, which was 16e to the minus 7 over 2. And what we said previously was k was greater than 0 from the original question there. So that value and that value are coming from 16e to the minus 7 over 2 and 9 there, which is giving me this bit here as my answers. So it's quite complicated. You might need to look at that a couple of times. It's not the most straightforward of questions. But this style of question seems to be occurring more and more in the recent ones. So really important one for you to have a look at. Okay, hopefully that all makes sense to you.